Hello all. Today we're talking about secondary data analysis. So what is secondary data? We've talked about surveys and other sources of data. Secondary data is any data that another researcher or team of researchers has collected, but which you analyze. It can be a whole range of data, but usually refers to survey data that others may have done. You request, sometimes pay for access to raw data that those researchers have produced, including a code book and samples that were collected and so on. The goal is to conduct statistical tests and interpret the results. So what is the methodology with secondary data? It's a positivist methodology, meaning you aim for replicability. Anybody else using the same data should get the same results. You're working deductively. You have ideas about what you expect to find in the data. You form hypotheses. You pick questions and data that may answer those hypotheses, and you see if you're right. And that's why it involves testing hypotheses, making sure that you have an idea ahead of time and that you have questions you're asking of the data. So what are the research questions that work well with secondary data? They're often the same as any survey. They're ones that can look for social and demographic trends, self-reported behaviors, attitudes, level of knowledge, and to some extent, causal relationships. It's not good for how people see the world, or complex emotions, or meaning. That's far better for interviews and more qualitative methods. Now, what kinds of literature reviews help you with secondary data? They can help you write and refine a research question, seeing what other people have asked, seeing what questions are left. You often see other people's hypotheses and see how they might map onto the hypotheses you can test. May identify important variables in a data set, variables that you may want to test with other variables and other correlations. You can also see how variables have been operationalized, taking concepts and seeing how people are measuring them in the data sets you might be interested in. And once you have your results, having that literature review means you can compare your results to that previous research. And it may help you identify the secondary data sources you might want to use for research. You'll hear about a great data set, whether you're interested in like the Latino experience and you find out there's a data set of 2,000 interviews that would be great for the kind of research you want to do, or another data set that had lots of questions about elections or about like people's religious beliefs, all of which might fit your particular hypothesis. Now, what are the ethics with secondary data? You still might need an IRB review since you will have access to raw data. And you have to be careful, most of all, not to violate participant confidentiality. Now, the one thing is you don't have to worry about informed consent or other issues related to the conduct of a survey since somebody else has already done that. And usually you won't have individual names or ways to identify people, which gets rid of most ethical worries for you as a researcher. So how do you prepare for data collection? First, there are many different data sets available, so you'll have to think about which ones you want to use. The General Social Survey, which we'll be using most of all, is conducted biennially every 2 years. There's also the US Census American Community Survey, which on top of the main census, which is done every 10 years, this is done more often as another widely used secondary data set. There are other data sets for narrower concerns, but often go more in depth in those areas. There are a whole range of what's called data repositories, universities and other institutions that hold on to data sets of a whole wide variety that you can contact for, and they often put their data sets online and make them available to researchers. What you need to do is choose the data that will include the variables you need and sample the population you desire to see from. So what are Some of these popular data repositories, this is from your book. You can see a few different. There's things like the Roper Center for Public Opinion Research. You can see Pew Research Center for the People in the Press, which we've often referenced. This is important, and we're going to talk more about this. The University of California at Berkeley Archive of Social Science Data. They also store this General Social Survey, and they have a very useful interface that we'll be using to access much of that data. There's also things like the UK Data Archive, information about the United Kingdom that may be of interest, and a whole range of others. So, thinking about the secondary data, what are the steps in conceptualizing and operationalizing? First of all, you have to think which variables available match the concepts you're addressing in your research question. Has the data set you're using really measured what you want to measure, i.e., they asked the questions, but were they the questions you'd want to really capture the concept you're thinking about? That is another way of saying, will you be able to test your hypotheses? Will the correlations you'll be able to test, will they actually match the broader concepts you're trying to see if there is some basis in reality? You may at times need to recode a variable, meaning you may regroup data in new ways, such as in a question about race, taking all the non-white variables into a single person of color variable, or otherwise rearranging data into the groups that are useful for your particular research question. Recoding is probably the lengthiest process beyond analyzing to really think about, yeah, you have this raw data, but are there ways of grouping it into the categories that really work for the research you want to do? So, once you have the data, what kind of data analysis can you do? You're going to use a whole set of statistical tools, from everything from crosstabs, which we've talked a little bit about, frequencies, and other tools to explore the data. Keep in mind the quality of data being used and how well the variables fit the hypotheses you're testing. So, what kinds of relationships between variables can you explore? In a table, we often say that if there's a negative relationship between two variables, if, for example, the level of education is compared to the belief in spanking. If, as the higher the level of education is in the data, the less likely the respondent is to report believing that spanking is necessary, we call that a negative relationship, meaning that as one variable increases in value, the other decreases. A negative relationship is because the value of the independent variable, in this case, we're assuming the level of education is causing people's beliefs in spanking, so that the level of education is the independent variable. As it goes up, the value of the dependent variable, in this case, the belief in spanking, goes down. Conversely, if higher levels of education were associated with increased levels of agreement that spanking is necessary, we would say there's a positive relationship between those two variables. Now, having found that there's a correlation of some kind between two variables, can we then say there's a causal relationship? Generally not with just a simple correlation. You don't want to infer too much, especially from a bivariate crosstab. We can't know if the relationship between level of education and belief in spanking is really a causal one, that the level of education is actually causing the belief in spanking. There may be an association, a relationship between the two variables, but how do we know, or what's the mechanism that the level of education may be causing the belief in spanking? The worry is the relationship could be what we call a spurious one. A spurious relationship meaning that there's another variable, a third variable, that's affecting both the level of education and the belief in spanking. For example, you might find that those with higher levels of education come from families with less traditional beliefs about the family and less belief in spanking. So it's, did you grow up in a less traditional family that is the real causal factor? Whether that's true or not is aside, but I'm noting there are other variables that could be affecting both people's levels of education and their level of spanking without one directly causing the other. Those spurious correlations are why you use what are called control variables, third, fourth, and sometimes fifth variables to see if they are actually important in whatever relationships that may appear. Here are the general rules for arguing for causality. There must be association between the variables in some form. The independent variable, if you can show that that came into existence before the dependent variable, that people believed in spanking at one point in their life, and then they got higher education and you measured their beliefs then and their beliefs in spanking had decreased. That kind of temporal order is more of an indication of causality than a sort of static association. There are other ways to look at this as well. If you explore hypotheses and check that are there correlations with other variables that might themselves be causing whatever your dependent variable is, but yet those correlations don't show up through your research, and the only correlation that seems significant in the end is your original one, that's a stronger argument that it's a causal relationship when no other causes seem to be in place or other correlations being particularly strong. So how do you evaluate the quality of the data you have? I mean, much like the surveys we talked about before, which you conducted, you have to wonder, are the survey questions reliable? Were they understood in the same way by every respondent? Every respondent must ideally be asked the questions in the exact same way, in the same order. There's also measurement validity. Measurement validity means that the indicators you use in a survey are measuring the variable that you think they're measuring, i.e., that you've operationalized the original concept effectively, and what you ask actually maps on to the broader concept you're interested in. Most complete possible sampling frame, meaning you have the highest response rates and also the least amount of missing data. All of that yields higher quality results. So what are the solutions to get better measurement validity? I mean, one way is you make sure the indicators you're using were used by other researchers and they had strong justification for using them. And then you can compare your results to their indicators, making your research that much more robust. You sometimes ask multiple questions about a similar concept, especially if the concept is complex. Like if you're interested in people's views on abortion, there are multiple ways to ask about abortion, and you can see if your hypotheses hold up in those different ways of asking about the concept of abortion or whatever other subject you're looking at. There are also more complicated statistical tests called factor analysis that see how well the responses to items hang together, i.e., if 10 items measure quote unquote being in love, and respondents who say they are in love have answered those questions with few or no contradictory responses, then you have some evidence that your items are valid and grouped together in something that maps on to together these ideas of being in love together. So what are you going to do once you have your results? How do you present them? You first want to discuss your research question, the methods to collect the data, information about the sample you use, procedures that were used to collect the data, meaning you have to understand how the secondary data you used was produced in the first place. You want to highlight the statistical patterns, the correlations that you found in your analysis. You'll present your statistics using tables or charts, as well as describing them orally or in writing. And here's one thing, you want to focus on the strongest results you get, but also the weakest, and any of the more surprising results you found that you didn't expect. If your results differ significantly from those of other studies, you'll probably want to offer at least an educated guess as to how the results differ, raising questions of additional research to do in the future.